Okay, next to ratio test, I did put a little note there, but that's actually about the line above. It's just to point out that if the absolute value of the terms in a series, the summation of the absolute value converges, then so does the original series. Absolute value gets rid of all the minuses. So if it converges without any minuses, and then you let the minuses go back in, that'll converge too. The other way around might not happen. If you get rid of the minuses, sometimes that'll diverge. Like the example we saw just a minute ago with 1 over n. If it has minuses, as in negative 1 to the n over n, that converges. But if you get rid of the minuses, that diverges. So now for the ratio test. I had to squeeze that note in there. But the ratio test is underneath here, and it's these three conditions. All right, this is again a comparison where you compare terms of the same sequence to themselves. So you don't compare it to another sequence, you compare the nth term to the n plus 1 term. That means what you're comparing is how close the terms are together as they get bigger and bigger. So we look at the limit as n goes to infinity of a sub n plus 1. Think of that as being the next term, divided by a sub n. Now, if that turns out to be a constant value L smaller than 1, then the summation n equals 1 to infinity of a sub n is absolutely convergent, which we can say because there's absolute value bars around the original, around the stuff inside the limit there. If it turns out that that limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n equals L greater than 1, then the series diverges. And if it lands right on 1, it's inconclusive. I think we have some examples of this here next. Okay, I'm going to come back to that interesting looking table at the top. That's for a problem further down. So here's an example though. N equals 1 to infinity, negative 1 to the n cubed over 3 to the n. Now these tests, typically I'll tell you which one to use. I'll say try using the ratio test, and then you'll know what to do. So first of all, figure out what that ratio looks like. A sub n plus 1 divided by a sub n. So what that means is that I'm supposed to put in an n plus 1 for every n. So you got to look in that original formula inside the summation and find all the n's and replace them with n plus 1's. There's 3 n's and they all turn into n plus 1. Negative 1 to the n plus 1, n plus 1 cubed, over 3 to the n plus 1. Then in the denominator, I just copy what I had originally. Don't replace anything. Negative 1 to the n cubed, 3 to the n. Then you do the algebra. Okay, so let's see. First of all, the absolute value bars are nice because they get rid of those minus 1's. Minus 1 to any power is either plus 1 or minus 1. The absolute value is just 1, so I got rid of all that. Then on top I had n plus 1 cubed over 3 to the n plus 1. You'll see that. And then I multiplied it by the flip of that fraction on the bottom. So times 3 to the n over n cubed. Now it's all positive, so I don't need absolute values of bars anymore. They just got rid of the minus 1 for me. Alright, now I'm supposed to take the limit of that. So I'm taking the limit of what I just found. N plus 1 cubed times 3 to the n over 3 to the n plus 1 times n cubed. And let's see. There's some immediate simplifying that I can do. 3 to the n on top and 3 to the n plus 1 on the bottom can be simplified. So those are the same base. They're both factors, so I can simplify the exponent, and I get n plus 1 cubed still, and just 1 on top, and only one copy of 3 left on the bottom. The 3 to the n cancels with the 3 to the n. So I just have 3 on the bottom and n cubed. Now I take the limit as n goes to infinity. I need to figure out what n plus 1 cubed is. You actually just need to FOIL it out. It turns into n cubed plus 3n squared plus 3n plus 1. And then on the bottom, 3n cubed. So that's a rational function with the same degree on top and bottom. So it equals 1/3, which is less than 1. So that by the test means that the answer converges. On the left, there's a limit there I'll mention for the next example.